Hello guys and welcome back to the sim here in Brunei. In this episode we're going to create a brand new 3D printed MCP. This has been months in the making, trying to make it as simple as possible. So the first big problem I had was getting the large parts. Now this is nearly 470mm long, and of course that doesn't fit on most printers including mine, so they had to be created in smaller parts but strong enough to fit together and support themselves. So that's the back plate. It just slots together and it forms quite a solid unit. That's without the screws and the attaching hardware so far. The face plates are also printed in two halves and they slot together in the middle. The join will be noticeable, there's nothing you can do about that. You can see that the face plates are fully printed in grey PLA. I've done this for ease of construction. It was never designed to be backlightable, and the whole purpose of this 3D printed unit is to show how simple it is to build, create, wire and program. I'm going to move away from Prosim in this version and hopefully use Mobiflight's new event software. This primarily is going to be aimed at the new PMDG 737 for Microsoft Flight Simulator 2020 early next year, hopefully January, February. So I've got my face plates, I'm going to put them down on the board here, and of course the text is raised, which hopefully is going to make it really easy to fill in with a white paint pen. Now I get asked this all the time, what paint pen do I use? Well, I'm here in Brunei and I can honestly say there's not that great a selection. I just go down to the stationery shop and ask for a white paint pen, and all it says on the front of it is zebra paint marker. It is, however, ideal for this job. I'm going to shake it up, I'm going to refresh the nib. What I'm going to do is just gently dab on top of the text. Oh, it's coming out fast because it's a new pen. And while I'm down here doing this, don't forget you can pause print and change the print colour to white so it does it all automatically for you if you don't fancy paint penning it. And what I've done this time is, because this is 3D printed, I've made the text much larger so it comes out really well while you 3D print it. Quickly scanning to make sure it's all done. I'm quite happy with that. Oh, we've got a bit missing off the S here. Yep. And now we can start the build. Start with the back box. This is very simple. We've got our centre box and they are hopefully just going to push together like so. We've got our Arduino brace, which also backs as a support for the join. This time on the design front, I've tried to use just two sizes of screws, and that's the M4 by 10mm and the M3 by 8mm, to make it simpler for you guys to get the parts. That's the first box section, rock solid. Time for the next part, and of course that's just the other end. The two parts simply slot together and then we put the brace in the middle, back over on its side, and with those 8 screws we've now got the back box completely built. And just to prove it is rock solid, that took a lot of design work to create that, so I'm quite pleased with it. Okay, got a bit ahead of myself. Okay, next up is the Arduino support. is going to slide over the 4 posts, hopefully. It does. Another 4 screws, M4. These are the Arduino mounts. And they are just going to bolt in to the guide. Here's our Arduino Megas. We've got 2. I'm not actually sure how many we're going to need, but rather than be short, because you can use this space in the back here if you want to fit eFish units to the left and right, and then fit all the Arduinos in this rear space. Oh, that is much better. Okay, hopefully some M3 screws to hold them down. Next up, I like using these Arduino prototype shields. You can get the resistors in there and it makes everything really tidy. Also allows the whole unit to separate from the Arduino, so we're not directly wiring to it. And if we need to change the Arduino for a fault, it's just a simple case of popping these up and replacing the Arduino. Of course, now I need to solder all the header pins onto these boards. So on goes the soldering iron, and I'll quickly do that. This is the easiest way I've found to solder all the pins nice and level, is to put them into an Arduino and then just put the prototype shield on top and solder away. And the next part before we proceed is to fit some resistors. Now there are 14 KD2-22 momentary switches. They all need LED resistors, and also the 3 LEDs for the flight directors and the auto throttle. So that's 17 lines that we have to use. I'm going to use the first Arduino shield and put the resistors in. Now off camera I have checked the luminosity, I think that's a word, of the KD2-22 switches. The LEDs look fantastic, nice and bright. They are a little bit dim for the old, whoa, nearly dropped it there. They are a little bit dim for the green LEDs here. However, you don't actually want them too bright in the cockpit, otherwise they're going to blind you. So I'm going to stick with the 120 ohm resistors, and I'm going to put 17 of those in a line on the Arduino board here. Bear with me a second while I insert all these. So that's 13 down to 2. Just remember, you can't use pins 0 and 1 on the Arduino, so we're going to skip them straight into pin 14. "17 resistors, 120 ohms. Let's start the next section. So I've got the left hand base plate here, and we're going to start populating it with all the components in front of me here, and it should be fairly simple. Let's start with the LEDs first, and the only advice I've got for the LEDs is make sure you put all the anodes in one direction, so they all face to the left, your right, or all to the right, your left. Here we go. There's only 2 on this side, one for the captain's flight director. So I'm going to put the longer legs facing to the left, your right. They just slot in there, and I'm going to bend the legs over at the rear to hold them in place for the time being. Again, this one, so long leg to the left. In it goes. Bend the legs over, and that will hold it until we get the faceplate on. There we go, just clicked in fact. Next up, we've got the flight director switches, and they just simply push through and the nuts go on. There's no need to check the height because I've already adjusted the thickness of the PLA to make sure that the height of the protrusion of the switch through the panel is correct. And we've got another switch on this side for the auto throttle, which goes in that hole there next to the LED. Tighten that up. These two holes here are for the push buttons. Push them in from the back, they sit flush. And once again, the nut will go on the front. We need to turn the unit over and now fit the 7-segment displays. All you've got to remember is to put the header pins on backwards. Normally they stick out towards the top of the face of the 7 segments. I put them on backwards. They should fit into the slots. Let me get my electric screwdriver. And with the M3x8 screws, that is a little bit fast. There we go. I'm only putting 2 of the 4 screws in because 4 is a little bit excessive just to hold a 7-segment display in. That's the back panel for the left hand side done. Let's move on to the right hand side. That's this one here. Very much the same procedure. We're going to start with a push button straight into the hole with its locking nut. Tighten it up. We've got another LED. Anode to the left again. That'll make it so much easier when we come to wire it up. Then we've got the first officer's flight director switch. On goes its nut. Next up, we've got the AutoPilot disconnect switches. Now these are momentary and they're on, off, on, momentary both ways. But we're just going to use them in one direction. They're going to slide in. That's all the components fit to the front side. Let's flip it over and install the 3 7219 boards in. Again, with all the pins sticking out towards you on this side. Next up, we've got the VS wheel and the encoder. We're going to push the encoder into the VS wheel, like so. You really want to make sure that the 3 pins on the encoder are facing up. That's going to make wiring so much simpler. And it's just going to slot into the gap. We've got the encoder support. And we're just going to screw those together. So the encoder brace is done up just tight enough to hold it. And now, when you turn it over, the wheel feels quite firm, but very smooth. That's it for the right hand panel. I'm going to put that to the side, and now it's over to the face plates. These should be dry now, so I don't have to worry about touching them. And this is what they look like. I think that looks pretty cool. For me anyway, hopefully it does for you. And we've got to fit a couple of components to this unit too. And that's mainly the encoders, because they're face mounted along with the KD2 22 buttons. That really is a mouthful to say. Okay, here we go. When you insert the encoders, there are locating holes for the locating tangs. And there are these tiny little tangs that stick up from the base, and they should locate into the unit. Put the nut on. Now these nuts come with my encoder, so hopefully they'll come with yours as well. 10mm nut. Tighten it up, that's one done. On the left hand faceplate, we've got the 1x12 switch, and again that's got a locating tang and a locating hole. That's just going to slot into position. The nut goes on, and for me that's a 9/16 nut, and I'm going to kind of cheat here and put some of the knobs on. Okay, some of these knobs I've been prototyping already to make sure that they're the best fit for you guys to fit on. These knobs are designed specifically for the D-shaft encoders. They've got 3mm grub screws in, and they just slide on, he says. There we go, and we tighten them up. So that's not going to come off, and there it is. Then we've got the IIS encoder. That's going to go on there. Again, a little tweak to tighten it up, make sure it doesn't come off. Then we've got the heading encoder. That's going to go on there. And this is where one of the first differences you'll notice that have come in. You'll notice that I've had to split the encoder from the rotary switch because it's just so much simpler when you're starting out. So on the real aircraft, we've got these two switches combined. They go basically, they're dual concentric. I've moved them apart. It has no effect on the actual unit. It just looks a bit different. So if you're looking for an exact replica, this unit is not for you. This is to show how simple this unit can be to build. I need to put the 3mm grub screw in. There she goes. Now this isn't really needed on this one because it grips really tightly, but it does stop you from pulling it off. I'm going to grab my black marker and then just hopefully fill the raised text in. Done. Going to grab the right hand faceplate, and we've got a couple encoders to install here. The altitude encoder, make sure it goes into the hole. Attach this securing hole. Same for the first officer course, in it goes, nut. And I think that's it for this side. I don't have to do anything more. I'm going to bring our two back plate panels back, and these were designed to fit together nice and snugly. They've got a little rail system in the ends here. So we've got the female rail system here, and we've got the male rail system in here. These should fit together, and they do, and that's how they look. And now, even without any screws in, it's quite solid. We can put the face plates on, so it's the right hand face plate first, and hopefully that's just going to slide into position. The left hand face plate is going to slide into position. It's got to move some of the switches around. Oh, that's good. That is good. Okay. And we're going to fix the face plates to the back plates with M3 screws. So that should be the face plates attached to the back plate, and I could already feel that's increased the strength greatly. And hopefully the join in the middle isn't too bad. So the last components, the last major components to go in are these KD22 switches. They're momentary, they're black, and they've got green LEDs. Now these were supplied by a Patreon that I couldn't get hold of them here in Brunei. They got them shipped from China to the UK, and then they were sent out to me. A massive thank you for doing that. It was just amazing. I'm going to insert these 14 switches now into the remainder of the square holes, and they seriously just push in and they auto lock into position, which is fantastic. It makes it very simple. Just make sure that all the LEDs face one way. It'd be very embarrassing if you fit an LED, one button is upside down. That's most of the knobs on. What we're going to do now is fit the AutoPilot disengage. Now this should slot on. It has got two 3mm grub screws to grip onto the shafts of the momentary switches. And we're just going to tighten those grub screws onto the switches. That one's good. That one's a little bit loose. That's better. And that feels really good. If I turn it round, now when you push it, there's a good positive click. Back to the front, we've got our bezel windows that need to go in, starting with the course. Okay, so this one's a bit loose. It wasn't designed to be loose. It should have gripped it and clicked it in place. I've obviously got something wrong. So out comes the crackle. And of course, it super glued the lid on. And I really am trying to put the minutest amount on so I don't make a mess. There's one. Okay. That one is also loose. In it goes. Now, considering these windows are all the same size, and now this one's a bit tight. Come on. Oh, that's actually perfect. That's how they should have been. They should have clicked into position. Now we've got the 5-digit display. That's a nice tight click. So is that one. And then we've got the final one. Yep. And that clicks in as well. And I do believe that is the front done. Wow. Does that look cool? That is the front section completely done. We now need to flip it over and wire it up. I'm going to daisy chain all the grounds and get back to you in a minute. You really don't need to see how to do that. I am basically going to connect a wire, I would like to say a black wire, but I'm going to actually use white wire to every single ground pin on every single device. Once that's done, I'll get back to you. I'll see you in a minute. I've been going for about 30 minutes now, and let me show you what we've done. We've basically connected a ground all the way along, so we've got a single ground wire coming out of the unit, and the only other wires I've connected so far are the 5 volts in for the 7-segment displays, and they too are daisy chained all the way along on the input side. Hopefully you can see in front of me here there are about 50 labels. They're the wires that now need to be attached to all the buttons, the switches and the LEDs and the encoders. Once that's done, I'll get back to you again. Catch up with you in a minute. It's been about another 10 minutes and I've managed to get all the lacing cord fitted. And there is the back of the unit, hopefully all wired up. And we're going to slide the panel and all its cabling into position. Just see how that sits. Not bad. And we'll get some screws in along the bottom to make it a bit more rigid before we go into wiring the Arduino prototype boards. So I'm just thinking right now that I've left a decent amount of length of cable here. I could snip these cables back, these cable ties back, and bring the loom round this way and through, which gives me a lot more room to play and move the boards around, rather than directly wire and then you've got no access to anything. So I actually am going to snip what I've just done on this top section. Here we go. Yes. And I think what we'll do is we'll bring the cables around the back into a nice big L, so we're using some of the length. We'll go through the brace and then onto the prototype board. So a bit of rerouting required. That means we want to take all the cables from the back here, from the center point onwards, out to the side. And we're back. The cables are now routed around the edge, so there's a lot more play in the cables if we need to move them around. I've also separated all the switches and encoders are going that way, and we've only got the LEDs coming in now. They're going to get wired to the prototype board next to the resistors, and that's going to be recorded on the sheets in front of me. And we are finished. That's it, fully wired. Hasn't been tested or programmed yet. That's the next step. Let me give you a close look of what we've done. You can see that we've used 2 Arduinos, but I think you really would have got away with just one. I can use these remainder pins for other items in the cockpit, such as the EFIS units bolted left and right. Because we're not having to separate the 7-segment displays, it means there's only 5 wires to each unit, and it makes the build so much simpler. It really is now just push the components into location and tighten them up. It's as easy as that. You can see from the inside that the wiring actually is not complicated at all. It's just basically a ground and a switch or an LED the whole way along. I guess next up is to connect this to the computer and start programming. Let's do that. I'm going to use this little 4-way hub. It's non-powered, but it's got 2 connectors, USB connectors for the 2 Arduinos, and I really think you would have got away with one if you needed it. But as we've got all that room in the back plate, it's also a good place for other systems to connect. So that's connected at the rear. Next up is to start programming MobiFlight, and of course first thing we need to do is go into the MobiFlight modules and tell it what devices we've connected to the board and each pin. While Microsoft Flight Simulator loads up, let's get the covers on, because hopefully I'm not going to need to get back in there, and it is all going to work first time. Now, so make sure I get them the right way around. They've got little radius corners on one side, and the outside covers need to go on first, and then the centre cover on last. Now on to programming, and if you're going to use Prosim and Microsoft Flight Simulator PPAR 3D, I've created videos in the past on how to use FSUI PC and all the offsets to create the MCP. We're going to take that step forward. MobiFlight has evolved over the last 5 years. They've put so much work into it, especially Sebastian, who is the founder of it. It is now pretty much a couple of clicks to program the MCP. I'm going to try and show you that with the new method. It's super simple. Unfortunately, PMDG 737 doesn't come out until next month. However, you can use this AutoPilot panel with nearly every aircraft on Microsoft Flight Simulator. I have trialled it, and because the heading is generic, the altitude hold, the flight director switch, generally they are the same inputs on all aircraft, and that means they work across the board. Enough waffle, let's do the first one. For the time being, let's go for the 747, because we can use the MCP from that. It's kind of similar, it's got a few bits missing. I'm just going to select the first airport we come to, Gatwick. Okay, let's fly, that will load up, and we're in. So I'm just going to focus onto the MCP panel. Let's zoom that in a bit. Let's close that. Close that. Come on. Wow, got a lot of panels open. There we go. So let's do heading first. So we need to make sure I'm in the output section, the output tab. And I'm going to label it as 7-segment heading. I'm going to open that up. Display first. going to be my left hand one, display module, and for me I think it's module 2. I'm just going to click 6, 7, 8 and push test and see what happens. Okay, so I'm in the indicated airspeed, wrong one. Let's try module 1. Perfect, heading 1, 2, 3. Stop. I am going to use left padding and I do want the zeros to display in front. Sim variable. Now this is where things become very simple. Wow. Give or take. For the heading, I'm actually going to use the 172 AutoPilot because it's the simplest. You can see that the 172 AutoPilot heading's auto-populated. What I need you to do now is click on it, select down and select it again, and then it inserts the variable. It didn't auto-insert, and I'm finding that every now and then it doesn't auto-insert and it won't work, and that's the reason why. It's because it's not populating. Here we go. Let's put OK. I'm going to highlight the line and then I'm going to push run, and it's got 256.9. okay, so it's slightly rounded down. That's workable. What have we got on the display? We've got 256, that's good. And if I change it, 250, and you'll find that the heading works across most platforms. 240, 240. It's that simple, 2 clicks. Okay. So we've got our heading display, nice and simple. Let's go over to the inputs and do the heading encoder. And that is, it's shown me already on the bottom here, but we've got no config for it. So all I'm going to put is heading encoder input. It's my left, oh, I've selected the right one, I've done it again, left hand. Device, heading encoder, there it is. On left, events. And for the heading encoder, I found that if we go to Microsoft, generic, I'm going to go to avionics this time, and we're going to select the A1000, the Garmin 1000, MFD, heading knob, there it is there, and we will go, so if we turn it to the left, we want it to increase, and on the right, I want it to decrease. Again, so generic avionics, find it, heading, decrease, hit OK. I've got to make it active, always make it active, and if it doesn't work you may have to stop and run it again. It's working, I can see it already. So I'm going to close my, I'm going to minimise mode, there we go, and you can see on the screen it's working fantastic, super fast, and then you can just fine tune it. In fact, I'm going down by 2s. Okay, so I actually can't select odd numbers, and I have a feeling that's because I'm going to go into Mobile Flight modules, left hand module, find the encoder, and I'm going to change it to 1 detent per cycle, upload, hit OK. So I think I may have selected the wrong settings there for the encoder. We're about to find out. I actually am going to stop Mobile Flight and run it again so it loads the code back in. Here we go. Better. Perfect. So now I can go up in single digits. What happens if I move it fast? No problem. 279, that's good. Let's do the heading hold button next. Heading hold button. I'm going to select the line. It's my left hand module again, and heading select. So on the 737 it's either called heading hold or heading select. What I want to tell you is that these buttons, the KD222s, are non-latching, they're momentary, which means we don't want to select the on-off version, we just want to select the state change. And to do that, again we're going to go into events, we're going to go into the group. So we're going to go into Microsoft generic AutoPilot again, and you can see already see we've got airspeed hold. What I want to find is heading hold. Heading hold is there, and of course if you've got a toggle switch or you've got a latching KD223 version, then you can select on and off. But AutoPilot heading hold works for non-latching buttons. It's basically what I'm trying to get across there. We're going to hit OK. We're not going to do anything with release. I'm going to activate that line. I'm going to minimise. Now to be able to see this, I'm going to come down to the screen. I'm going to push heading select. There we go. You can see that right here we've got heading select selected. If I push it again, it goes off. It's that easy. Okay, our KD222 buttons have all got LEDs in. Let's do that next. Back to MobiFly. Back to the output tab, and this time I'm going to call it heading hold LED. Right, so I'm going to select the left hand module. I know it's that. It is just plain old output. If I test it, you'll be able to see at the front. Good. And now for the groups, we're going to select again Microsoft generic AutoPilot, and we're going to select heading lock. There it is. It's inserted the variable. I'm going to hit OK. I'm going to make the line active. Hopefully that'll work now. If I flip back to Microsoft Flight Simulator, let's look at the screen. If I push it, we get the green LED. We also get heading select on the screen. Release it. That's how we do the heading. Next up, let's do the flight director. That's a toggle switch. So what I'm going to put in the inputs tab here is flight director switch. Here we go. Edit the line. It's going to be my left hand module. It's called Captain's Flight Director. On press. Let's go for events again, and I'll scroll down to what we're going to try today. Let's try the TBM AutoPilot, and let's see if it's got a toggle switch in there. AutoPilot, Flight Director. There, yep, there it is. Flight Direct toggle. I'm going to hit OK. Over to there. It's off. It's off on the unit. On. Off. And it didn't work. Oh. And the reason it didn't work is because I have not activated the line. Let's try that again, shall we? Here we go. So it's off on the screen. The flight director is located here. I'm going to switch it on. On it goes. You can also see that it's doing, well, that should have gone off and it didn't. Okay, so it's gone on but it hasn't gone off. And it's gone on because I've toggled it off. Okay, now I'm not going to be able to get it back into position. Oh, I am. There we go. And that is because I've not done the on release. Yeah. Events. Back into TBM. TBM AutoPilot. Flight Director toggle. Hit OK. Come back out. So we're off on the sim. We're off on the panel. On is on, off is off. Toggle switch done. I can see everything works fine on the 747. Let's try another aircraft and see what happens. My laptop is getting extremely hot. Okay, let's change the time and date just to help us see the cockpit a bit better. I'm about to turn all the lights on. Real time. Come on. There we go. Let's get rid of that. Let's zoom in. So the heading bug works on there. Does it work? Yes, it does. So even on the G1000 it appears to work. What else can we adjust to see? Can we do altitude? So as you can see, across a multiple set of platforms, you can use the AutoPilot panel. Absolutely chuffed with how this has turned out. And remember, you can get the files free from the website. They're the STL files. It's about 25 items to print, and you'll be able to create this. What a fantastic DIY build for any sim. Yes, it's predominantly made for PMDG 737, which hopefully will be released in January, February of 22. With Moby Flight's event list, programming has never been simpler. Every time a new aircraft comes out, the community gets together and produces the event list, which you've seen me select from. Hopefully it'll get its own little chapter, its own little parts, so you don't have to go through all the different aircraft, and you'll just be able to select the PMDG 737 options. Okay, it's a fantastic bit of kit. It's an easy DIY build. There is a little bit of wiring in there. However, it's good for the basic desktop unit. Now there is no backlighting, as I said before, because it's 3D printed. Backlighting does work, but it takes a lot more effort. This is designed just to sit on your desktop, be a simple build and get you going. You can get the STL files for free from the website www.737diysim.com, and you can build one of these. Okay guys, that's it for this episode. I hope you've enjoyed it. Go and get the files, give it a go, and I'll catch you later. All the best. Sim out from Brunei.